seen one question from one of your friends. Let me check, because I cannot check here. Where is the test 2 will cover what chapter? Okay, we are going to have our lab test after the lecture on Thursday. Okay, lab test 2. Yeah, the one that I mentioned just now is not the lab test 1, but test 1. Okay, so test 2, I'm not sure the best time for test 2 because you have mini project. Can you have many projects? So maybe most probably I will combine the lab test with test 2 on Thursday. So it will cover from correlation regression onwards. Okay, correlation regression onwards. It means that correlation regression and t-test. T-test, and then another one is Anova for independent sample. So Anova for dependent samples and non-parametric method is not included lah. Yeah, it's not included in your assessment. Okay, ada soalan lain? Boleh faham ke semua? So it will cover correlation, regression, and then t-test and Anova for independent samples. So 4 topics. So if we have 4 topics, you can assume that minimum number of questions that I will give you will be 4 questions. That is the minimum number of questions. Boleh semua?
Boleh.
Okay. Now let's discuss about Anova for dependent sample. So you don't have to worry too much about Anova for dependent sample. This one most probably important for the mini project. Okay. So for the mini project, since that I put the deadline for the submission on Friday, right? So I will extend the submission time, right? I will extend it, and then we will discuss about the poster presentation later on after we finish our lecture tonight. Okay, Anova for dependent sample. So it means analysis of variance for dependent sample. Okay, and then unlike the Anova for independent samples, the way we carry out the analysis is slightly different. It's slightly different, and then I can admit that the procedure is slightly confusing. Yeah, so you need to pay attention. Yeah, in our lecture tonight. So keep on coming. So we will look at the assumptions for the Anova for dependent sample, and then I will go straight to the case study. Okay, the case study, I only give you one case study and how we write the hypothesis statement, and then how we should enter our data, record our data in data view, and then we will go the procedure step by step. On how to analyze it using SPSS. Then we will look at all the SPSS output available from the viewers, and then on how to interpret the outputs. Okay, so what you need to know about the Anova with repeated measures, it means that you have you measure the same subject or the same group a few times. Okay, a few times. So when I said that to compare 3 or more group means the group actually referring to the group of observations, not group of the subjects. Okay, so to compare 3 or more group means where the subjects or participants are the same in each group, meaning that we have the same group and then we measure them a few times. Okay, a few times. So as you can see from the slide, we have time point 1, time point 2, time point 3, up to time point K. So if we have K time points, it means that we need to perform Anova with K dependent samples. Yeah. So to compare 3 or more groups where the subjects or participants are the same in each group. So the design of experiment for this type of analysis is called repeated measures or within subject experiment or treatment by subject design. So these are the keywords that you need to remember related to ANOVA with dependent samples. Sometimes published papers, okay, they use different kind of terms. So sometimes it makes us confused, right? So normally it depends on the discipline area, which terms that they prefer to use, okay? So we have two conditions here. The subjects or participants are measured multiple times to see changes to an intervention. Okay, so from time 1 to time 2, we have one intervention. From time 2 to time 3, we also have another intervention, and so forth. Okay. Condition 2 is the specimens or participants are subjected to more than one condition or trial, and the response to each of these conditions wants to be compared. So we have participant under condition 1, condition 2, condition 3, condition K. So there are two types of design experiments. Either the subjects are measured multiple times to see the changes, or the subject or the participants under different kind of different trial or different conditions or different treatment. Okay, and then we want to see the difference in the measurement or the assessment for each of the conditions, right? So now that is the background of the ANOVA for dependent samples. So there are 5 assumptions, and if you can see from here, the first and the second assumptions okay. The first assumption is similar to the ANOVA for independent sample, where the dependent variable must be in continuous level. So when we say continuous level, is either interval or ratio. And then the second assumption will be the independent variables, which is the categorical variable, represent the related groups or the match pairs. Okay, meaning that the independent variable is the categories or the level or the subgroups which refer to the measurement taken from the same subject or the same participants. The third assumption is there shouldn't be any significant outliers in the related groups. Okay, it means within groups. Yeah. And the fourth one, the distributions of the dependent variable in the 2 or more related groups should be approximately normally distributed. So I underlined the word approximately normally distributed. So it means that for the ANOVA with dependent samples, they are quite robust with the non-normality. Yeah, quite robust with the non-normality. It is sufficient to have the distribution approximately normally distributed. Okay, so sometimes, so when I say approximately, sometimes maybe the p-value from the Shapiro-Wilks and the Kolmogorov-Smirnov test, normality test, doesn't give you the value above the alpha value. Okay, above 0.05 or 0.01. But if you see that the shape is symmetrical, slightly symmetrical, or the coefficient, the skewness and kurtosis coefficients are within the acceptable range, then you still can proceed with the ANOVA. Okay, so it is quite robust with the non-normality. And then the fifth assumption is sphericity. Okay, sphericity means that the variances of the differences between all combination of related groups must be equal. So we don't use the terms homogeneity of variances here because we are not looking at the variances for from each group. Okay, what we are focusing on here is the variances of the differences between all combinations of related groups. Yeah, we assume that the variances of the differences more or less similar. So this is what it means by sphericity. So if I want to explain further, let's go back to the previous slide. So from time point 1 and time point 2, we have a difference. How can I have the marker here? Boleh ke ada marker? Pointer options. Okay. Yeah. Okay. So this one we have different one. Okay, delta 1 between time point 1 and time point 2. Okay, we have delta 1, and then here we have delta 2. Okay, so this is the second differences. Let's say we have time point 4 here, so we have here delta 3. So this delta, okay, so if we have 10 observation, means that we have delta 1i, okay, so I equal to 1 until 10, okay, 1 until 10, okay, because we have 10 observations, for example. Okay, this is 2i, and then this is 3i. Okay, so the distributions of the differences, okay, data 1i, data 2i, and data 3i must follow approximately, the differences, we have the variance, right? So when we have the delta 1i, delta 2i, so we can also have delta bar, kan? The average of the deltas, the differences, okay? Right, so we also have delta 2 bar, okay, the average of the differences from the second difference, okay, the second between point 2 and point 3, and so forth, right? So when we have the deltas and we have the mean, then we can find the standard deviations of the deltas, okay? So the standard deviation of the delta, or the variance of the delta. So the variance must be the variance of the differences, okay, for delta 1, delta 2, and delta 3 must be supposed to be similar or homogeneous. Okay, so that is how I can explain about the sphericity. Okay, what it means by the sphericity. Right. Any question about that? Any question about the assumptions? Do you understand the concept of the assumptions? Let's see, how can we find the outliers? This one is very easy. You can look at the histogram or the PP plot. Okay, if you find any points that is quite far from the main groups, then you have an outlier there. Okay. Okay, next, let's have a look at the case study. So from case study, we have 7 subjects. Okay, we have 7 subjects, and then we have drug 1. Okay, drug 1, so treatment 1, and then drug 2, meaning that treatment 2, and then we have drug 3, treatment 3, where all these subjects need to take. Okay, so let's say the subject take drug 1, and then after 2 weeks after they flush out all the effect of the drug 1, then they will try drug 2, and then after 2 weeks after they have they flush out all the effects of the drug 2, then they will try drug 3. Okay, something like that. So the data below shows the result of an experiment in which blood cholesterol concentration in milligrams of cholesterol per deciliter of blood, okay, was measured in 7 subjects after each subject had been treated with one of each 3 drugs. Okay, 1 drug at a time, with time allowed between exposure to each drug to allow its effect to disappear from the animal. So if you want to know, the animal actually refers to mouse. Okay, The hypothesis of interest is that the mean blood cholesterol level is the same regardless of the treatment. Okay, that is the hypothesis the null hypothesis statement. Okay, the mean blood cholesterol is the same regardless of the treatment. Okay, that is the hypothesis null statement. So the hypothesis statement will be like this. The mean cholesterol level is the same in animals on all 3 drugs. And the alternative hypothesis statement will be the mean cholesterol level is not the same in animals. Okay, this is this is incorrect. It's not the same in animal at least, okay, on one of the 3 drugs, okay, not on all, okay, at least on one of the 3 drugs, okay. So here, at least one of mu I is different from others, okay. Can you please correct the statement here? Okay, do the correction, the necessary correction for this statement. The mean cholesterol level is not the same in animal, at least on one of the 3 drugs, okay? So let's say mu1 represent the mean cholesterol level from drug 1, okay? And then mu2 is the mean cholesterol level from drug 2. And mu3 is the mean cholesterol level from drug 3. Okay, so we can also write our hypothesis like this. Okay, and then you need to key in your data similar to the way you key in your dependent sample t-test. Okay, since that you know that in data view in SPSS, this one row means one subject or participant. So the value from the same row related to the first ID, okay, the first subject, okay, must come from the first subject, okay. So they supposed to be an overlap here. So we have 3 points overlap there, okay. So the way we key in our variable view is like this, okay. Drug 1, drug 2 until drug 3 in different rows in the variable view so that we can get the header in different columns in our data view. Okay, so most of you actually got it wrong in the last question in your test 1 on how to find the mean and standard deviation for species, for gender, and gender female species too, something like that. So most of you unable to explain correctly on how to get that analysis. So most of you lose your mark on that part. Okay, ada berapa tu? Ada 16 points there. Most of you got 5 and below. Okay, now so the procedure. All right, so first of all we need to test the assumption. So we can test the normality and the outliers using procedure explore. Okay, how to get explore procedure? You go to analyze and you need to click on descriptive statistic, yeah, not descriptive analysis, not descriptive frequencies, or so many of you make mistake here. Okay, click analyze, descriptive statistic, and then explore. Okay, so analyze, descriptive statistic, and then we have another drop down list. You click on explore. This is how to check the normality and outliers. For sphericity, you need to go to transform and then you need to compute the differences. Okay, you need to compute the differences. So you go to transform, compute variables, and then you let's say the target variable is difference 1, 2. It means that the difference between time point 1 and time point 2, or the difference between drug 1 and drug 2. Okay. So this is the expression. And then you need to, and then you click OK, and then you repeat again, this time between drug 2 and drug 3, and then between drug 1 and drug 3. So that's why we end up with 3 measures of differences. Okay, difference between 1, 2, difference between 1, 3, and difference between 2, 3. And then for the normality and explore just now, okay, then we can perform the ANOVA. So how to perform the ANOVA? We go to analyze and then general linear model. Yep, because this is for dependent sample, we can only assess from GLM, and then choose repeated measures. Remember, first click analyze and then general linear model. Okay, and then repeated measures. And then it will open this dialog box, as you can see from the slide. Okay, so in the slide, we can see that the dialog box has listed 3 variables, drug 1, drug 2, and drug 3. What you need to do is transfer all these 3 into the dependent list. Okay, because they are not categorical variables. Yeah, they are continuous variables, all right, from different drugs. Okay, and then after that, you go to plots, and then check the normality plot with test, because we want to assess the normality here. All right, and then we're supposed to get what the result of the normality test. And then for the to perform the ANOVA, you need to go to GLM just now. Yeah, here performing ANOVA, you need to go to the analyze GLM and repeated measures, and then this dialog box will appear, this one. Okay, and then it says here factor 1. So what should we do? So we need to know what our factor is. Our factor is drug, because the variable, the categorical variable is drug, right? That is the category. So I change factor 1 into drugs, and then they ask here the number of levels. The number of level is 3, because I have 3 different type of drug. And then I click add here, and then drug in bracket 3 will appear in this box below. Okay. And then after that, I need to declare the measure name. The measure name means the variables, the dependent variables. Okay. The dependent variable is the cholesterol level. Okay. So I declare the measure name is cholesterol level, and then I click button add, and it will go to the second box here. Okay, so the confusing part is these 4 dialog boxes. Yeah, so you need to, so the challenge in analyzing data using ANOVA dependent sample is the most challenging one is to identify the factor and the measure name. You need to understand your data. If you don't understand your data, then you will be unable to name it correctly. Okay. So here we have cholesterol level, we have the factor is drug with 3 levels, and the measurement is the cholesterol level. So click already defined here. Okay, click define. So when we click define, another dialog box appear here. Okay, so what I need to do is I will click one by one and then transfer to the next box here on the right. So once I click drug 1, then drug 1 will be in this space. It will replace the question mark. Okay, and then when I click drug drug 2 will go to the second question mark. And then when I click drug 3, it will go to the third question mark. And it become like this. Okay? It will become like this. And then click OK. Okay? You can click OK, or you can go post hoc and options. So let's say that we go to plots. So here plots. Okay, we want extra, we want a supplementary output to help us to interpret the result. So let's say we click plots, and then this one will appear. So what I'm going to do is I just drag into horizontal axis. Okay, into horizontal axis. And then because this is one-way dependent sample ANOVA, so I don't have to put anything on separate lines. Okay, if I have two categorical variable, then I can use these separate lines. Okay, so drugs, and then I will ask for line chart instead of bar chart. Okay, I will ask for line chart, right? So when I put the drugs on the right box, what I need to do is, as usual, I need to click button add. It will go to this one, this box. Yeah, that's why you can see from here. This is the difference. Okay, and then automatically this chart type will activate it. So the line chart is the default setting for the chart type. Okay. So if you choose bar chart, then you can have additional feature, which is error bars. Okay, error bars. Right. So this time I just choose line chart. You can try yourself later to use bar chart for the plots. And then after that, I click continue. When I click continue, it'll go back to this dialog box. Okay, it will go back to this dialog box. And then this time, I click another button, which is options. So another button is here, options. The last one. Mana saya punya cursor ni, saya tak nampak. Okay, the last one. And then option. So when I click option, okay. So when I click option, so I will get this dialog box, right? And then, sorry, not this one, yeah? When I click option here, I will get the second dialog box. So this is the measures that we request. So I will ask for descriptive statistic and then effect size. Okay, the significant level I maintain to the default setting, which is 5%, right? And then click continue. And then another thing that I can ask is estimated marginal means. Yeah, this one. Okay, right? Estimated marginal means. So I will ask for SPSS to display the means of drugs and then try to compare the main effects. So we have only main effects here because we only have one categorical variable, which is drugs. And then click continue. Right, so this is the output from the normality test. As we can see from here, the cholesterol level for each of the drugs are normally distributed because all of the p-value are greater than alpha 0.05. Okay, so we refer to the Shapiro-Wilks only because the degree of freedom is 7, which is it shows that the sample size is small. So Kamogrosminov is not the suitable one. So we need to use Shapirovic test, even though the conclusion is the same, but we stick to Shapirovic's because of the small sample size. And then all the p-value 0.694, 0.702, and 0.912, all of them are greater than alpha 5%. So our conclusion is all the samples follow Gaussian distribution. And then when we are checking the outliers, remember just now when we choose the Kolmogorov-Smirnov and Shapiro-Wilks, we will obtain the QQ plot. Okay, so we can see from here all the 7 points for each of the drugs, all of them are close to the straight line. So there is no outliers. Okay, there is no apparent outliers. And then for the sphericity, as we can see from here, the variants are totally different. Okay, huge difference. Okay, the difference between drug 1 and 2, the variance, we can look at both actually. So the variance is 33. The difference between 1 and 3, the variant is 106, and between 2 and 3, the variant is 207. So the difference between 1 and 3, triple, more than triple from the difference in 1 and 2. And then whereas for the difference between drug 2 and 3, double from the difference in the variance for the difference between drug 1 and drug 2. So they are not similar. Okay. And then for the, so it means that the sphericity, the assumption for the sphericity has been violated. All right. So there's something that we need to do later on. Okay. And then for the Anova, for that, okay, that's all about the test on the assumption. Okay. Now we want to test the mean between drugs. Okay. So we can see from the first table of the Anova, it will give you the descriptive. It says that we have 3 types of drugs, and the name is drug 1, drug 2, and drug 3. And then they have the second box, which shows the mean and standard deviation and the number of observation. So as we can see from here, the highest mean cholesterol level from drug 3, sorry. The second highest from drug 1, and the lowest from drug 2. Okay, and then even though the drug 3 has the highest mean cholesterol level, the standard deviation also the highest. Okay, and then same goes to drug 2. Even though the mean is the lowest, the standard deviation also the lowest. Okay, now as we can see from here, when we test the sphericity, so this is another test of the assumption for the sphericity. We call it Mockley test of sphericity, right? And then what you need to look at is the significant value, okay? The significant value where the P is equal to 0.028, which is less than the alpha value. So if we write our hypothesis statement for our Mockley test, the alternative hypothesis will be one of the sigma is differ from any of the other sigma. At least one of them differ from the others. Okay, so here there is a significant difference in terms of the variances of the differences. Okay, now since that the sphericity is not assumed, so in testing the main effect, we need to choose greenhouse gas instead of the first one. So we will use the second p-value instead of the first one, because the first one is under sphericity assumed. But unfortunately, ours is not. So we need to choose the greenhouse gas, okay, as our method to measure the mean effect of the drugs. So the p-value that we obtain here is 0.009, which shows that there is a significant difference in terms of the cholesterol level between treatment. Okay, and since that we have 3 drugs, then we need to perform multiple comparison, the post hoc. So here we carry out pairwise comparison. And then the pairwise comparison, the p-value has been corrected using Bonferroni correction. Okay, Bonferroni correction. And then we found that drug 1 is significantly different from drug 2 in terms of the cholesterol level. So the difference is 11.857, meaning that drug 1 is give cholesterol level significantly higher compared to drug 2. Okay, so it means that even though you consume drug 1, okay, your cholesterol level is still significantly higher compared to if you consume drug 2. So kalau begini, bermaksud drug 1 ke yang lagi bagus, drug 2 yang lagi bagus. Anyone would like to try? Franisha Mona? Which one is better, Franisha Mona? Unmute yourself.
I think drug 2.
Yes, drug 2. Because it means that drug 2 will give a significantly lower cholesterol level compared to drug 1. That's what it means by this multiple comparison. Okay, and then we can see that drug 2 and drug 3, there is also a significant difference in terms of the cholesterol level with mean difference negative 20.286. Okay, so in this case, Adriana, ada? Adriana, so mana satu yang lagi bagus, Adriana, untuk menurunkan cholesterol level, drug 2 or drug 3? Adriana?
3.
Drug 3. Okay. Arman Idlan?
I think drug 3 itu. Drug 3 juga.
Okay. Arman Idlan pun cakap drug 3. Okay. Kita tanya lagi seorang lah. Andrea?
In my opinion, drug 3.
Okay. Ashraf?
Drug 3 also.
Okay. Bella Ryan?
Drug 3.
3 juga. Daniel Lim Jin Yi?
Doktor drug 3.
Drug 3 juga. Okay. Nur Atika?
I think drug 3.
Okay. Iqbal? Iqbal? Mana Iqbal?
Boleh dengar Kak?
So
Doktor?
Iqbal, drug mana yang lagi bagus? Yes, I can hear you, Iqbal. Drug 3, okay. Iqbal juga cakap drug 3. Okay, Siti Yasmin. Semuanya jawab drug 3. Siapa yang ada opinion yang berbeza? Boleh saya tahu? Cuba angkat tangan. Emoji angkat tangan. Ada tak?
Ada, saya rasa drug 2.
Siapa tu? Siapa yang jawab drug 2 tu? Tadi yang bercakap tadi? Terus hilang
Saya,
sekejap.
doktor.
Sorry, saya tak dapat tengok kamu punya apa tu? Siapa yang nama? Saya tak dapat tengok because blocked by the
JP.
PowerPoint. Okay. That's good. Jawapannya drug 2, bukan drug 3. Saya rasa yang jawab drug 3 ni kan kawan seorang dah jawab 3, yang lain pun semua 3 nak selamat. Ataupun kalau tak selamat pun tak apalah, sama-sama tak selamat. Salah, you all kena fikir, jangan ikut kawan. Okay, drug 2. Kenapa drug 2? Kalau dalam kita kolesterol level, kita nak rendah ke nak tinggi? Amanda, kolesterol level lagi tinggi lagi baik ke lagi rendah lagi baik?
Lagi rendah lagi baik.
Okey, lagi rendah lagi baik. So, kalau the mean difference adalah negatif, dia tulis itu I tolak J dapat negatif 20. I itu adalah drug yang kolom pertama. J itu adalah drug pada kolom yang kedua. So, I tolak J maknanya 2 kolesterol level drug 2 minus kolesterol level drug 3, you dapat negatif. Itu menunjukkan nilai mana, kolesterol level mana yang lebih tinggi? 2 ke 3? Ayu Rashidah. Ayu Rashidah.
Maksudnya drug 2. Drug 3 lagi
Maksudnya
tinggi.
apa Ayu Rashidah?
Maksudnya drug 3 itu lagi tinggi dia punya kolesterol level.
Kalau dia drug 3 lebih tinggi kolesterol level, adakah dia lebih baik?
Tidak.
Tidak. Okay, so tadi kawan kamu dah dapat jawab bagus dah yang ini. Tapi kenapa kamu confuse yang ini? Saya tak faham. Ya, ini positif sebab drug 1 lebih tinggi kolesterol level daripada drug 2. Okay, so it means that drug 2 can actually decrease your cholesterol level significantly compared to drug 1. But antara 2 dengan 3, you dapat difference negative 20. It means that nilai 2 ini lebih rendah daripada nilai 3. That's why kita dapat negative. So it means that drug 2 also can decrease your cholesterol level significantly compared to drug 3. Itu maksud dia. Okay. Now, kita pergi kepada kedua ini. So, kalau kita lihat di sini, ini adalah dia punya EM plots. Ya, estimated marginal means plot. Kita akan lihat di sini drug 2 jauh ke bawah. Drug 1 and drug 3 tinggi di atas. Okay, itu pun sudah memberikan makna yang dah bagi hints pada kamu mana satu yang bagus. Okay. So this is how we report our analysis. Cuba tengok betul-betul. The first one, I mentioned here, a repeated measures Anova with a greenhouse gas correction. Why? Because we have sphericity problem. Okay. Determine that mean blood cholesterol level differed statistically significantly between drug types. Okay, memang terdapat perbezaan yang signifikan. Okay, dengan dalam bracket this one. Okay, so ini kita panggil APA style. APA, all alphabetical order, all capital letters. Untuk kalau dalam akademik, kalau kita nak report result analysis, ini kita panggil APA style. Ya, kalau you tak tulis APA style, kamu punya paper kena rejected. Now, the second one is post hoc test using the Bonferroni correction reveal that treatment with drug 1 caused an increase in cholesterol level compared to the treatment with drug 2, which was statistically significant. Okay, P 0.05. And then post hoc juga menunjukkan, reveal that treatment with drug 3 cause an increase in cholesterol level compared to the treatment with drug 2. Okay, in another way to look at it, between the 3 drugs, you will suggest medication using drug 2 because it will not increase the cholesterol level. Kalau you guna drug 1 and drug 3, you ada side effect, iaitu you punya cholesterol level akan meningkat. Itu maksud dia. So it's very important to know that. So however, treatment with drug 1 and drug 2 did not show statistical significant difference in cholesterol level. So it means that drug 1 and drug 2, both of them give an increase in the cholesterol level, and then the result between them are similar. Okay. Kita tak boleh cakap drug 1 lagi meningkatkan cholesterol level daripada drug 2. Sama saja drug 1 dan drug 2. Walaupun mereka berbeza, tapi perbezaan itu tidak signifikan. So, therefore, we can conclude that the level of cholesterol of the subjects is depending on the drug treatment, in which a treatment with drug 1 and drug 3 can cause a significantly higher cholesterol level than the treatment with drug 2. So, at the end, we can also close the statement says that it is safer to receive a treatment using drug 2. Something like that. Because it will not increase your cholesterol level significantly compared to drug 1 and drug 3. Okay? So dia ataupun you boleh cakap bahawa it will not increase the cholesterol level as significant as drug 1 and drug 3. Okay, so you guna your own sentence lah, berdasarkan your own kefahaman. Okay, so that's it untuk Anova for dependent sample. Ada apa-apa soalan? Any question? Anyone? Tak ada? Setakat ini tiada, Doktor. Thank you, Fatihah. Okay. So kalau tak ada, kita rehat sekejap 5 minit sebelum kita sambung dengan non-parametric method. Okay? Okay, take a break for 5 minutes. Okay, semua sudah scan attendance ke? Saya nak bagi kawan kamu yang lain pula scan. Okay, ada kita minta yang lain pula ya. Franisha, you belum lagi kan Franisha? Okay, Franisha, you boleh scan dulu. Sepatutnya Franisha dengan Nurul Nabila kan? Okay. Untuk biotek sudah semua sudah scan ke? Ada belum ke? Semua sudah? Supaya saya boleh tulis ini. Kalau belum beritahu cepat-cepat. Semua sudah ya? Okay. Saya tutuplah. So now kita pergi kepada the next one, which is non-parametric method. Okay. Non-parametric method. So this is the last chapter and this is the easiest one. Okay, this is the last chapter and the easiest one. Okay, so you already learned about t-test, independent sample t-test and dependent sample t-test, as well as the Anova for both independent and dependent samples. So let's say if you have problem with the normality and then you unable to increase your sample size to improve the distributions of your data, then you don't have enough observation to do any transformation to improve the shape of the distribution of your data. Okay, so it means that if you already take into consider all the other methods and then you are unable to proceed with the other approach, then the last options that you have is to perform non-parametric techniques or methods. Okay, so here I will give you a few examples of the non-parametric method. Okay, so the chi-square test you already learned. Okay, the chi-square test you already learned. So we will not discuss about it any further because it's already discussed during our correlation topic, right? So we will discuss about Mann-Whitney and Wilcoxon test as well as Kruskal-Wallis and Friedman test. Okay, so if it's easier for you to remember, for the Mann-Whitney U test, oh I forgot U here, suppose we have U, capital letters, okay, Mann-Whitney U test, sepatutnya ada U kat sini, okay. This one is the alternative for independent t-test, okay. This is the alternative for independent t-test. And then for the Wilcoxon test, we have two types. One for independent t-test, and then another one for dependent t-test. Dependent samples t-test. Right? So that it will be easier for you to remember. So for the independent t-test, the Wilcoxon test is known as Wilcoxon sum rank test. Oh, what happened? I'm supposed to share it. What happened? Okay. So it's supposed to be Wilcoxon sum rank test. Okay, and then for the dependent sample t-test, the name of the Wilcoxon test is Wilcoxon sign rank test. So jangan confuse ya, right? So we have two Wilcoxon tests, right? The Wilcoxon sum rank is the option for the independent t-test if the data is not normally distributed, and Wilcoxon sign rank test is the option for the dependent sample t-test if the data is not normally distributed. Okay, for Kruskal-Wallis, this one is the option for the Anova for independent sample. Okay, whereas fragment test is for the Anova for dependent sample. So I hope you can remember this well. Okay, itu pasangan-pasangan dia. Okay, those are the pair or the pasangan ya. So Man Whitney berpasang dengan independent t-test. Okay, and then Wilcoxon test berpasang dengan both t-test. Depends on whether kalau dia sum rank, ini berpasang dengan independent t-test. Kalau sign rank, okay, ada beza di sum, ini sign. Okay, kalau sign rank, dia berpasang dengan dependent sample t-test. Anova pula berpasang dengan Kruskal-Wallis, Anova for independent sample, whereas fragment test adalah pasangan bagi Anova for dependent samples. Okay, boleh faham ya? Right. Now, kita lihat apa maksud non-parametric. Okay, alright. First of all, you need to understand what it means by distribution free test. Okay, maknanya tidak ada assumption on the distribution of the data. Okay, so distribution test itu tidak memerlukan apa-apa assumption tentang the shape of the distribution of the data. Okay, distribution free tests are statistical analysis that do not rely on any underlying assumptions about the probability distributions of the studied population. So it is called distribution free test. So the branch of inferential statistics devoted to distribution free test is called non-parametrics. Okay, ataupun dalam bahasa Melayu dia dipanggil ujian tak berparameter. Okay, so non-parametric statistics ataupun non-parametric test, they are different ya. Test statistik ya. The test using non-parametric statistics. Okay, based on the ranks of observations are called rank statistic or rank test. So all these are rank tests. Okay, rank test. Right, dan dia punya statistic value adalah rank statistics. Okay, so that is the difference between them with independent t-test. Independent t-test dia punya statistics adalah statistik T. Okay, kalau dependent test also statistik T. Anova statistik F. Okay, Anova statistik F, and then Anova for dependent sample adalah statistik apa? Tengok di sini. Mungkin saya tak tunjukkan tadi dalam output. Okay, statistik F. Okay, you all nampak ke? Oh, kamu tak nampak yang ini ya. Kamu nampak yang PowerPoint. Statistik F juga ya. Okay. So ini pun statistik F. Kalau chi-square test, chi-square test, statistik apa? Chi-square. Okay. So kalau untuk non-parametric method, the statistic adalah rank statistic. So there is different ways on how to compute the rank statistics, different ways. Now, it depends on the type of the non-parametric test. Right, let's have a look at the first rank test, which is known as Mann-Whitney U test. Okay, Mann-Whitney U test. The population being compared are not normal. That is the reason why we use the non-parametric. This is an alternative for two sample T test or two independent sample T test. Okay, I forgot to mention independent here. Right, so the assumption independent random sample of size N1 and N2. So the 1 and the 2 supposed to be the subscript. Okay, N1 and N2. Okay, so the procedure on how to run Mann-Whitney U test is you have two set of observation. Okay, from 1 and then from 2 with different observation, right? So what you need to do is you combine these two, okay, combine them together, and then assign ranks to the sorted value. So you sort the value, let's say in ascending order. Okay, let's say this one ada 5, okay, this one also ada 5 observations, okay. And then when you susun, you ada 1, 2 observation hinggalah 10. Right, because you combine them. Okay, regardless whether they come from group 1 or group 2. And then you sang the ranking. So we have the rank here. Okay, so this one rank 1, maybe ini rank 2, and then maybe 3 and 4 are ties. So this one will be 3.5, the ranking, because we need to average the rank if there are ties. So this is also 3.5. Okay, and so forth. Okay, and then what we need to do is we will average rank to any ties. That's what we did here. Okay, and then the test statistic T is defined as the sum of the ranks for the observation in the first sample. Okay, the first sample, it depends on which sample that you define first in your data view. So, different people might get different T. Okay, jadi bila you buat lab test ke ataupun analisis ke, jangan kamu tengok kawan lain. Ya, mungkin dia define sampel lain dahulu. Kamu define sampel kedua dahulu. Okay, so maybe slightly different. Right, so do not follow your friends because it depends on how you key in your data. So test statistic T is the sum of the ranks for the observation in the first sample. What you need to do is, okay, this is an example on how we are going to do it. Let's say you compare the running speed of the first year students, boys and girls. The following information is collected. Okay, so kita ada 11 orang and then this is the rank. Okay, kita masuk, maknanya kita tak ada raw data dia. Kita sudah diberikan rank and there is no ties. Okay, and then let's say the first one, kita ada 2 group, boys and girls. So in ascending order, we have this. Okay, all right. So now we want to find any difference between the running speed of boys and girls. What we will do is we will regroup the rank into boys and girls. So we have 5 boys. Okay, 1, 2, 3, 4, 5. So we have 5 boys with the corresponding rankings 2, 7, 8, 9, and 11. Okay, so the rank sum will be 2 plus 7 plus 8 plus 9 plus 11 give you 37. And then do the same thing to group girls and then you will have the rank sum 29. Right? So this is the hypothesis statement. Okay, hypothesis statement for the Mann-Whitney test is similar with the independent t-test. So let's say we have a two-tail test at alpha 5%. Okay, so what we need to do is we just key in the data. The data looks like this. Since this is independent sample, so for the independent sample, we must have one categorical variable in one column, the grouping code. So we have gender in one column and then the ranking in another column. Okay, so we go to non-parametric tests, and then you can also use independent samples here, but I prefer to use the legacy dialogues. You can try the other option yourself, but I will only discuss using the legacy dialogues, and then go to independent samples. This is the reason why I choose legacy dialogues, because it gives you a clear choices in the drop-down list. Okay, legacy dialogues, and then choose two independent samples. When you click that, you will get this dialog box. Okay, similar to the independent t-test, right? Okay. So here it says two independent sample tests. So the rank goes to the test variables because it is the test statistics, and the gender goes to the grouping variables, and you need to define the group as usual, the same way how you define your groups in your independent t-test. Right, so you define group 1 and 2, and then click OK, and then you will get this output. So it says here 6 girls, 5 boys. The boys has the mean rank higher than the girls, and the sum rank also higher. Sum of rank also higher compared to the girls. Okay, so the Mann-Whitney U give you the rank as 8. Okay, and the Wilcoxon give you 29. So 29 means that they took this one girl because girl came first in the output. So it means when we define the data, we define the girl first. That's why the Wilcoxon W will take T statistic 29. So this statistic actually can be normalized. Okay, can be normalized or standardized, become Z. Okay, I don't want to teach you that because it is not important for you. For the mathematics student, yes, it's important for them. But for the biotech student, it is not important to know how we standardize it. Okay, all right. So once we standardize the sum of ranks, 29, it becomes statistic Z. Right? Why do we need to normalize it or standardize it? Because if we remain as the statistic remain as Wilcoxon W statistic, we cannot find the p-value. The p-value can only be computed using standard normal probability distribution. That's why we always transform all the rank statistic into Z statistics. Okay, all the rank statistic, regardless what the rank test is, will be transformed into the Z statistics to enable us to compute the p-value. So once it has been transformed into Z, so the 29, the T statistic 29 become the Z statistic negative 1.278. And the p-value is 0.247, which is greater than alpha 5%. So there is no significant difference between boys and girls in terms of the speed in running. Okay, all right. So there is no difference. So we cannot reject the null hypothesis. Okay, we cannot reject the null hypothesis. So the null hypothesis is whole as true. Right. Now, the Wilcoxon test, as I mentioned just now, has two independent samples for independent sample and for the dependent sample. Okay. So now we have other tests for the Wilcoxon, which is median test. Okay, so Wilcoxon rank sum test use the other statistic which is called R, sum of ranks in smaller sample. So the Z statistic is obtained like this. This is how we transform R, the sum of ranks just now, become Z. Okay, so you don't have to remember or memorize this formula. All right, so when the Wilcoxon R equal to 37, let's say if I choose 37, okay, because we have just now 29 and 27, remember? Okay, so from table Wilcoxon rank sum with N1 equal to 5 and N6 equal to 6, the critical value is between 19 to 41. Since that 37 or 29, whichever, right, is within the interval, it means we cannot reject the null hypothesis. So we use this R similar to the way we use 0 in our confidence interval for the independent t-test, if you still remember. Okay. In the independent t-test, if the 0 is within the 95% confidence interval of the mean difference, it means there is no significant difference. So the same concept applies here. If the Wilcoxon rank sum statistics, okay, 37 or 29 within the critical value, where did I get this critical value? From the Wilcoxon rank sum table, okay. It means that there is no significant evidence to reject the null hypothesis. So we do not reject the null hypothesis. So conclusion is, we conclude that there is no difference in the speed of boys and girls. So that's how we got it. Okay. Now, the next one is Wilcoxon sign rank test. Okay, sign rank is for dependent sample. Okay, for dependent sample. So the procedure is similar to the Wilcoxon sum rank test. Okay, we just sorted the values, but in this case the absolute values of the differences. Okay, not the raw data, but the differences. Okay, from smallest to largest, it means in ascending order, and then we assign ranks to the absolute value. And then we need to find the sum of the ranks of the positive differences. Okay, of the positive differences. If the null hypothesis statement is true, then the sum of the rank of the positive differences should be about the same as the negative one. Okay, so another test which is similar to the Wilcoxon sign rank test is sign test. Okay, sign test, but it is quite it is not strict and then very difficult to reject the null hypothesis statement. So the sign test is very easy. Okay, very simple. It is only refer to the median of the differences. Okay, and the test statistic is the number of positive differences. So it's very simple, right? And if the null hypothesis is true, then the number of positive and negative differences should be approximately the same. So they use the same way on how to interpret the result for the Wilcoxon sign rank test. Should be about the same. Sama je. Okay, the positive and the negative signs, the number of positive and negative signs. So X, let's say it is actually can be related to the binomial probability distribution, where X is defined as the number of positive differences, or the successes is the positive differences. Okay, so the binomial with N, the number of trial or observation, and then we set the probability of success is 50% or 1/2. Right, so let's have a look at the example so that we can actually perform the analysis in theory. So let's say you have in average number of seeds in 2 pots. So you ada 2 pots lah. Was recorded at both the top and the bottom of 10 plants. Okay, so we have 10 plants, and then the number of seed kita letak ada yang dekat top, ada yang dekat bottom. Okay, the objective of the study was to determine whether the position on the plant affected the number of seeds in the pots. Okay, so kita lihat macam mana. So we have the top one, and then we have the number of seeds. Okay, this one when the location is at the top, and then this one when the location is at the bottom. From the same plant, okay, from the same plant, right, but different location. All right, so different location we can assume as different treatment. Yeah, and the subject are the similar subject, the 10 plants, right? So what we need to do is, we need to find the differences first. So here, top minus bottom. So the question is, can we do bottom minus top? Yes, we can. Yeah, yes, we can. You will get the same conclusion at the end, right? So 4 minus 4.4, you get negative 0.4. 5.2 minus 3.7, you will get 1.5, and then so forth. Okay. Now, the next step is, okay, you already compute the differences, and then the next step is you need to assign the ranking. Modulus ranking. Okay, the modulus value. Okay, regardless of the sign. So now, for 0.4, it seems like we have two occurrences for the value 0.4. Okay, so I cannot put, let's say we do it in ascending order, right? So the first supposed to be ranking 1, and then the second 0.4 supposed to be ranking 2. But I cannot give different value of ranking to both of them because they are the same value. So this is what we call a tie, right? A tie. So what should we do with ties? We need to average the value. Okay, the value of the differences? No, the value of the ranking. So ranking 1 plus ranking 2 is equal to 3, and then we have 2 equal values. So 3 divided by 2, we will get 1.5. So both of the values share the same ranking, which is 1.5. Faham ke tu? Show thumbs up if you understand. Kurang faham. Iqbal kurang faham ya, Iqbal? Okey. Iqbal 0.4 ni paling rendah, paling kecil. Ya, tetapi nilai dia berulang 2 kali. Okey, sepatutnya nilai yang paling rendah kita bagi ranking 1. Nilai yang kedua rendah kita bagi ranking 2. Kita boleh buat begitu kalau nilai itu berbeza. Let's say 0.4 and 0.5. But unfortunately, the lowest and the second lowest are the same value. Okay, the same value. So we cannot assign ranking 1 and ranking 2 to the same values. Okay, so we need to average the rankings. So ranking 1 plus ranking 2, 1 campur 2, 3, and then there are 2 similar values, then 3 bahagi dengan 2. That's why we get 1.5. Faham, Iqbal? Okay. Now, so we have ranking 1, ranking 2, so we need to look for the third lowest. The third lowest is 0.6. Oh my God, that is also a tie. Okay. Now, so we're supposed to assign ranking 3 for 0.6 and ranking 4 for the second 0.6, but we cannot do that. So there is a tie. So we need to average the ranking. So ranking 3 plus ranking 4 equal to 7. 7 divided by 2 is 3.5. 3.5. Okay, so the next ranking will be ranking 5. So the next lowest is 0.5, 0.7. Thank goodness there is only one 0.7, so we can put ranking 5. Okay, the next lowest is 0.7, so the next lowest is 1, and also only 1. We only have one ones, okay? So the ranking is 6. All right, and then continue. The next one is 1.4, so the ranking is 7. The next smallest is 1.5, but unfortunately we have a tie here. So rank 8 plus rank 9 divided by 2 is 8.5. And then the highest is 4.9, so we can assign ranking 10. Now, the sum of the positive rank is, so the positive rank is, kita tengok negative rank lah paling senang. Negative rank adalah di sini 0. The ranking dia, mana lagi negative? This one. And then 0.7, right? Sekejap Saya delete lah supaya kamu tak confused tengok. Okay, so now kita ambil yang mudah lah. Yang negatif adalah yang ini. Saya tengok yang sini Lagi yang negatif adalah ini. So the sum of ranks bagi negative ranks adalah ini. Ini pun negatif. So yang ini. So 5 plus 1.5, 6.5 plus 1.5, we got 8. And the rest, when we sum them up, we will get 47. Okay, so what should we do next? So what we need to do next is, kenapa ni? Right, so we need to find the T. T is the statistic for the Wilcoxon sign rank test, which is the mean between the minimum value between R plus and R minus. So this one R plus is 47. This one is 8. So the minimum value between 47 and 8 is 8. So that's why we have T equal to 8. Okay. So we need to go and find the Wilcoxon sign rank table. Okay. And then find the interval and see whether the 8 value is within the interval or not. If it is within the interval, then we cannot reject the null hypothesis. If the value of 8 is outside the critical value interval, then we can reject the null hypothesis. Now, how about sign test? Just now Wilcoxon sign rank test. Now sign test. Okay, it use very simple approach. Okay, we just want to see how many negative and how many positive when we subtract the number of seed from the bottom from the number of seed from the top. Okay, so we get negative here, negative here, negative here. So 3 and 7. Okay, so the position of the plant does not affect the number of seed in the plant, the pots. That is the hypothesis statement, null hypothesis statement. This is the alternative hypothesis statement. Okay, so let's have a look at the result if we use SPSS. Okay, so we go to non-parametric test and then legacy dialogues and then 2 related sample. Analyze non-parametric test, and then legacy dialogues, and then 2 related samples. right? So the SPSS application, so this it is similar to the dependent sample t-test. When you click top, it will go to here. When you click bottom and then click the arrow button, it will go to here. All right. So and then you choose Wilcoxon and sign as well if you want to. So yang the other two, please disregard. Okay, ignore it. Now, so when we click the top, it will go here, and when we click the bottom, it will go here, and then we click okay, or maybe you want to click option for the statistics. Okay, so this is the output that we obtained from the Wilcoxon sign rank test. Okay, so we have the number of negative ranks is 7, bottom minus, or this one, I did bottom minus top, the other way around. Okay. All right. So it becomes 7 and 3. So 47 and 8. So after we standardize the T, the minimum between these two, I will get the Z value equal to negative 1.992. And then the P value is less than 5%, less than alpha. So we have a significant difference of the number of seats between two different locations, top and bottom. Okay, so if we look at the critical values from the Wilcoxon sign rank table, right? So the n for n equal to 10 is 10. Okay, so since that the T is 8, which is less than 10, we reject the null hypothesis statement and conclude that there is sufficient evidence to suggest the position on the plan affect the number of seeds in the pots. How about the sign test? Okay, if we look at the sign test, we have 7, this one bottom minus top. Okay, I did it the other way around as well. So we have 7 and 3. Okay, and then p-value is 0.344, which is greater than alpha. So there is no significant difference. Okay, so if we look at the values of the sign test, if I follow the binomial probability distribution or simply look at the number of the sign here, 3 versus 7, definitely it is not similar. Okay, it is not similar, right? So here in the sign test, it says greater than alpha, there is no significant difference, right? So it's the other way around. So using the output from the sign test, we have the Z critical value 1.2649 from binomial probability distribution. Okay, so it is less than 1.645, right? Therefore, we do not reject the null hypothesis and conclude that there is insufficient evidence to suggest that the position on the plant affect the number of seeds in the pot. So if you can see from here, you will receive a contradicting result between the sign test and the Wilcoxon sign rank test. Am I right? Okay. So do not feel disturbed about this because the sign test is a very lenient test. So normally it is difficult to get a significant difference. Okay. So Wilcoxon sign rank test is stricter. So it is normally we refer to the Wilcoxon sign rank test instead of sign test whenever the sample size is small. Okay, because it's difficult to get accurate result from the sign test. Never mind. Okay, now let's have a look at the next test. This is the option for the Kruskal-Wallis test. This is the option for the Anova independent sample. So look at the conditions similar to the Anova. We have case sample which are random and independent. It means they are not overlapped with each other. And then we must have, okay, this one is not, this is specifically for Kruskal-Wallis, you must have at least 5 measurement of 5 replicates in each samples. If not, you cannot perform Kruskal-Wallis test. Okay. So this is the hypothesis statement for the Kruskal-Wallis test. And then this is the test statistic for the Kruskal-Wallis, where the R again stand for rank sum. Okay. And then the Kruskal-Wallis test, the statistic of the Kruskal-Wallis test can be transformed so that we can use chi-squared probability distributions. But no need to worry about this because you don't have to memorize the formula. This is just for additional knowledge. Okay. Whenever you have ties, you need to average the ranks. Okay, similar to the way we did on the Wilcoxon rank sum test and Wilcoxon sign rank test. So let's have a look at the example for the teaching methods. So we have 3 teaching methods: formula method, equation method, unitary analysis method or analysis method. Okay, sorry, we have 4. I forgot about this one. Case method means that you learn by case study. Formula method means that you learn using formula only. Equation means that you use equation. What's the difference between formula and equation? So do not ask, okay? Assume that there are 2 different methods. And then unitary analysis method, different method as well. And then we have average test score. And then each method we assign 1, 2, 3, 4, 5, 6, 7 students. Okay, 7 students. Now, what should we do? We key in the data similar to the way we key in independent t-test. We must have 1 categorical variable in 1 column. Yeah, case, formula, equation, unitary analysis, and the test score means the dependent variables in another column. After we finish keying our data, you go to analyze and then non-parametric test and then go to legacy dialogues. This time we go for K independent sample. So in this case, K is equal to 4. Okay, because we have 4 methods. And then the dialog box is similar to the independent Anova independent sample t-test. Okay, so teaching method goes to grouping variables, test score goes to test variables, and then Kruskal-Wallis has been selected. This is the default setting. If you want to add, you can add median. So it becomes like this. Okay, so you need to define the range of the code for the method. So we have 4, so 1 until 4. So this is the example of the output. So it shows that teaching method using case study will have the lowest mean rank of the test score. And the unitary analysis method can give you the highest mean rank of test score. So when they compared, okay, the mean rank, when they transform into chi-square statistic, so we can compute the p-value based on the chi-square probability distribution. Okay, and then here it is less than alpha, so there is a significant difference in terms of the test score between 4 different methods, right? And then let's say if we want to see the median test, okay, so we will look at the median value of the test score. So the median value is 24.92. So where did we get the median value? So we arrange all these score in ascending order, regardless of the method, and then we find the median. Okay. And with the median value, we will count how many observation greater than the median value and how many is less than or equal to the median value. So as we can see from here, there is a significant difference between methods. Yeah, it is quite obvious because if you can see from the unitary analysis, all of the test score is above the median value. But for the case method and for case study method and formula method, the test score majority below the median value or equal to the median value, below and equal to the median value. Whereas for the equation method, more or less similar. Okay, the number of the test score below and above the median value. So that is for the Kruskal-Wallis. For the fragment is the option for the Anova for dependent samples. Okay, so the treatment are randomly assigned, so similar, randomly assigned. The measurement can be ranked within blocks, so the treatment is considered as blocks, right? And then this is how we write the hypothesis statement. The test statistic for the fragment test is F, stand for fragment. So you don't have to memorize this formula, just for your additional knowledge. This is the rank sum. Okay, the rank sum, the rank statistics. And for the fragment test also will be transformed so that we can use the chi-square probability distribution in order for us to compute the p-value of the test. So let's have a look at the example. Let's say we want to bake not cakes, loaf, okay, meatloaf. And then we have in the oven is so big, we can put the loaf at 8 different location or position. Okay. Okay, which might differ due to the temperature variation. Mungkin yang di tengah lebih panas berbanding yang di tepi, atau di tepi lebih panas berbanding di tengah. Okay, so it depends on the type of the oven. Ada oven yang panas di atas, ada oven panas di bawah, ada oven panas di tepi, ada oven di keseluruhannya panas dan dia pakai fan di dalam oven. So siapa yang selalu bake a cake, they knows different type of ovens. Okay, so let's say 3 batches of loaves were baked in turn. Each batch consisting of 8 loaves. Okay, so we try to collect data, the percentage drip loss in meat loaves. Okay, drip loss. Okay, saat lagi banyak drip loss, maka kita punya loaf tu akan jadi kering, tak berapa moist. Ya, bila makan pun kurang sedap. So the collected data is the percentage of drip loss in meat loaves, the amount of liquid that drip out of a meat loaf during baking divided by the original weight of loaf. Okay, so this is the raw data, and then we have 8 position, and then each position we will put 3 loaves. Okay, 1, 2, and 3. Okay. So we have 3 batches, okay? 3 times lah kita buat, ya. 3 batches. So 3 batches ni boleh dianggap sebagai replicates lah, replicates from the same position. Okay. And then, so now when you key in your data, sama dengan the way you key in your data for the dependent samples. So position 1 until position 8. Okay, remember the row represent the same batch. Okay, the same batch. And the column represent different position. So you go to analyze non-parametric tests, legacy dialogues, and K-related samples. And then when you key in your data, it will look like this. Okay, we have 8 position, then transfer to the next box, and then fragment test already by default setting activated there. And then the output, very simple, only 2 tables. which shows the mean rank and the chi-squared statistic and the p-value which is less than the alpha value. So that is a significant difference in terms of the mean rank between eight different position. So if you can see from here, the lowest is position 2. Maknanya kalau letak roti kita dekat position 2, it will be very dry. Sorry, mean rank. Oh no, this is very good. Okay, because dia punya paling rendah. Okay, and then yang paling dry adalah yang ni lah, position 1. Okay, position 1 maybe similar to position 4. Okay, maybe yang moderate adalah position 6 and position 8. So how do we know which one is the best, which one is the worst? Because in non-parametric technique, we don't have multiple comparison or post hoc analysis. Okay, this is not on the slide, so please listen carefully. For the fragment test, can actually perform multiple comparison by performing multiple Wilcoxon sign rank test. Okay, then you need to do Bonferroni correction on the alpha or the significant level. Okay, so how to do the Bonferroni correction? It is by dividing the alpha with the number of where is this? The number of pairwise comparison. Okay, so that's how we do the multiple comparison. We can do multiple Wilcoxon sign rank test, and then we need to do Bonferroni correction on the significant level. All right, which is where the alpha will be divided by the number of pairwise comparison in that case lah. So for the fragment test here, we have 8 position. Okay, berapa pairwise comparison yang kita boleh dapat di sini? Anyone? Berapa pairwise comparison? Masih ingat lagi kamu punya basic statistik? Ada 8 pilih 2. Jadi berapa? Gunakan formula combination. Kamu belajar kan probability combination. Kalau ada 8 pilih 2 setiap kali, so ada berapa pairwise comparison available. Okay, mesti saya tengok siapa nama ada sini yang masih ada dan belum tidur. Sekejap siapa. Kalau yang besar. Alni Naziha. Alni.
Saya doktor.
Okay, berapa combination kita boleh dapat?
Saya tidak ingat lah doktor.
Right. 8C2 dapat berapa? Anyone? Cari kalkulator. 8C2 dapat berapa? Haifa Dayana? Haifa Dayana? 8C2 dapat berapa?
Kejap ya doktor, baru buka kalkulator.
Okay, siapa yang sudah buka? Iza Zulaika?
$28.
28. Okay, siapa lagi yang dah cuba? Betul ke 28? 8 factorial. Bahagikan dengan 2 factorial darab 6 factorial. So kita akan dapat 4 kali 7. So dapat 28. Betul. Siapa yang jawab tadi? Siapa yang jawab tadi? Saya tak nampak nama kamu. Okay, sure. So, good. 28. So, how to correct the alpha? So, alpha divided by 28. Okay, mana tadi saya conteng tadi? Where is it? Oh, yeah. So, kalau you nak buat multiple Wilcoxon sign rank test, apa yang kamu kena buat adalah alpha, katakan alpha itu adalah 0.5. So, here will be 0.05 divided by 28, which is very, very small, right? So, the more you the more the pairwise, the number of pairwise comparison, the more difficult to reject the null hypothesis statement. Okay? So, you punya p-value mestilah lebih kecil daripada 0.0018, barulah you boleh reject your hash null. Okay, it's very difficult, right? Okay, it's very difficult, but you can try. Okay, so balik. Okay, ini homework kamu. Alright. So you need to do the multiple Wilcoxon sign rank test with Bonferroni correction, and then you need to write to me what is the which position give you a significantly different grip loss. Okay. So untuk Kruskal-Wallis pula sama juga. You boleh buat multiple host analysis menggunakan multiple comparison. Okay. Multiple, ini paling mudah. Kita ada cara lain, tapi I just teach you the basic, the most basic ways. Okay. Multiple comparison of Wilcoxon rank test. Wilcoxon rank test. Okay. And then untuk case ini pula, dia punya Bonferroni correction adalah katakan 0.05 divided by the number of pairwise lah. Okay, in this case ada berapa? So ini ada berapa pairwise comparison untuk Kruskal-Wallis ni? Kita ada 4 method, every time kita pilih 2. So berapa? 4C2. Ada berapa cara? Anyone? .05 nak bahagi dengan berapa ni? 6. Yes, good. So, kita letak di sini bahagikan dengan 6. So, ini bersamaan dengan 0.05 bahagikan dengan 6. So, 0.05 bahagi dengan 6. Maknanya you kena dapat p-value you lebih kecil daripada 0.08 barulah you boleh reject your null hypothesis statement. Sorry, 0.08 pula. 0.05 bahagi dengan 6. Ya, 0.08 betul lah. Okay, 0.083. Right, so you can try and then tell me which of the pairwise comparison, which method actually significantly differ from which method. Because in the Kruskal-Wallis test, it gives you significant difference, right? So you need to find out which one is actually significantly differ from others. Okay, you need to tell me which one. Okay, same goes to the oven position. Which position actually give a significant difference in terms of the drip loss? So that is your homework. That is your lab work. Boleh semua? Faham ke? Ada soalan? Ada soalan? Okey. Kalau tak ada soalan, sekejap macam mana saya nak stop ni? Okey. Tak ada soalan kan? Ke saya tak nampak? Sekejap Okey, lab work bila hantar doktor? Malam ni boleh siap kan? Boleh. Okey. Lab work ini dia very simple saja. You just buat sahaja the Wilcoxon and the Wilcoxon sign rank test. Cuba dahulu, nanti hari Khamis kalau tak dapat atau ada masalah boleh tanya saya dan kamu boleh hantar sebelum 5 petang hari Isnin minggu hadapan. Is it okay everyone? Kalau okay, thumbs up please. Okay. Alright. So, cuba dahulu ya. Cuba dahulu, saya akan sediakan link untuk kamu submit. Itu sebagai lab work kamu. And then, kalau rasa tak faham atau rasa stuck, boleh tanya pada saya hari Khamis ini sebelum kita punya lab test and selepas revision. Okay? Boleh ya? Alright. So, saya rasa kita kena discuss about the mini project. So, wakil kamu Aina kata bahawa buat minggu ini amat sukar untuk dapatkan poster presentation, terlalu pack. So begini, you punya subjek ini tidak ada final exam. Ya, tak ada final exam. Kalau you saya tidak paksa kamu buat the poster presentation minggu ini kalau kamu terlalu pack. Okay. So kita boleh juga jadikan poster presentation ni you punya final exam lah. Ya, yang mana kita boleh buat sama ada dalam minggu study ataupun kalau you nak kita boleh buat dia sebagai SPSSD pada minggu terakhir paper final exam. So kamu boleh decide sekarang ataupun kamu boleh discuss dengan rakan-rakan kamu amongst you guys and then tell me what's the solution on Thursday. Is it okay? Macam mana? Ada opinion? Boleh beritahu saya setuju ke tak setuju ke? Setuju semua?
Doktor.
Apa siapa tu? Iqbal. Kenapa Iqbal?
Sorry, boleh doktor ulang balik tak? Macam mana tadi doktor?
Begini, sepatutnya poster presentation tu hari Jumaat ini. Tetapi wakil kamu Aina kata terlalu pack ya. Minggu ini kamu pack betul? Jadi Aina ada cadangkan untuk buat waktu study week. Tapi saya tidak berapa suka sangat nak ganggu study week because it's study week. Do you understand? So, since that kalau kamu nak juga study week then it's fine. Saya tak ada masalah. Okay? Tetapi mesti daripada kamu. Okay? Kalau kamu rasa bahawa tidak menjadi masalah untuk buat study week then we can do it on Monday. Tapi kalau kamu tak nak terganggu dalam study week, saya boleh juga buatkan poster presentation tu sebagai yang terakhir sekali dalam final exam because this subject tak ada final exam kan. So you boleh letakkan poster presentation tu after you finish your the last paper of your final exam. So you all boleh discuss mana yang terbaik. Sama ada kamu nak buat hari Jumaat ini ke doktor poster presentation nak buat online macam mana ya? Kan kalau online kita tak boleh buat poster presentation, kita kena buat presentation which will take longer because I cannot listen to your presentation berapa orang 20 group dalam satu hari, tak boleh. Kamu mungkin tak tired, saya lah yang tired. Oh, tak perlu decide malam ini. Ya, saya suruh kamu discusskan amongst you. And let me know on Thursday.